We're often taught a history of human progress that moves in a straight line. In this version, our ancestors were basic hunter-gatherers who slowly graduated to stacking simple bricks, building their way upward one layer at a time. But the physical evidence at Nan Madol complicates that narrative. This city sits on a living coral reef in the remote Pacific, constructed from 250 million tons of magnetized basalt logs. The logistics involve moving these massive volcanic stones across miles of open ocean to a reef with no natural land, using only local materials. We find similar anomalies in the North American desert at La Camada, a massive stone citadel featuring defensive pyramids and wide paved road networks. It sits in a region historical records describe as home only to nomadic tribes, yet nomads do not stop moving to coordinate the construction of heavy, static fortresses. Today, we're investigating 10 of these ancient sites to see how our ancestors managed fluid dynamics, zero-margin physics, and acoustic engineering. We're going to look at the evidence that suggests they weren't just a primitive workforce, but specialists in high-level mechanics. These physical realities threaten the simplistic history we're taught in school. They force us to ask how this level of technological foresight existed thousands of years before the Industrial Revolution. In Peru, the citadel of Sacsayhuaman features some of the most precisely fitted stone blocks in human history. These walls are composed of limestone blocks that can weigh as much as 120 tons. Simply lifting and custom fitting these irregular monoliths is a feat modern construction crews find difficult to conceptualize without the use of heavy hydraulic cranes. Despite their irregular shapes, the stands fit together with such precision that you cannot insert a single blade of grass between the joints, all without using a drop of mortar. This interlocking design was a functional seismic technology. Without rigid mortar, the wall can move. When an earthquake hits, these heavy stones are designed to dance and vibrate, absorbing the kinetic energy before perfectly settling back into their original positions. Engineering a self-healing wall using 100-ton stones proves a sophisticated understanding of kinetic energy. It moves the conversation past brute force and into the realm of dynamic engineering. Most construction is additive. You stack blocks upward and fix mistakes as you go. But ancient builders often utilized subtractive engineering, where they started with a solid mountain and carved deep downward into the bedrock. At Naqsh-e-Rustam in Iran, 4 massive facades were carved directly into a vertical cliff face. A worker dangling from a rope lacks the leverage to deliver thousands of high-impact strikes required to hollow out a mountain with a hand chisel. This method leaves no room for error. A single misplaced strike or a deep fracture would ruin the entire geometric shape. In modern experiments, primitive iron tools quickly warp and shatter against this dense stone, suggesting the use of advanced tooling. In the highlands of Ethiopia, this subtractive logic was taken even further. Standing on level volcanic earth, you look down into massive vertical pits, revealing 11 cathedrals carved entirely out of the ground. This required the architects to mathematically map out every vaulted ceiling and arched window in 3D space before removing a single piece of earth. They had to know exactly how the interior would look to prevent the structure from collapsing. The city of Jiahou in China is a massive military base built the exact same way. Rather than building upward, the architects started with a flat plateau and dug completely backward, hollowing out multi-story buildings, leaving natural dirt as permanent walls. Subtractive architecture represents a specific spatial challenge. It requires planning and 3D calculus that cannot be corrected once the stone is cut away, forcing a level of accuracy that primitive trial and error cannot easily account for. While these stone structures are impressive, some of the most advanced engineering is completely invisible. In the Maya city of Palenque, surveys of the underground Piedras Bolas aqueduct revealed a sophisticated mastery of fluid dynamics. To manage heavy rainwater, builders engineered tunnel walls that gradually taper inward downhill, forcing water into a tightening space. The resulting hydraulic pressure created a 20-foot fountain, allowing the Maya to run pressurized water directly into their homes. In the searing desert of Chogazanbil, engineers faced a different problem: how to provide clean water to a city. They piped in muddy river water from 40 kilometers away, requiring the construction of a multi-stage municipal water treatment plant. To filter the mud, the Elamites widened the brick channels to slow the water, allowing heavy silt to drop. Then they forced the water to seep through bricks fired to a specific porosity to act as a microfilter. At Uxmal, the Pyramid of the Magician features smooth, sweeping elliptical sides covered in thousands of individually carved stone mosaics. Achieving this curved geometry required the architects to calculate a shifting load-bearing radius at every single level of construction. The staircase acts as a massive acoustic instrument. Clapping at the base causes the specific dimensions of the stone steps to fracture the sound wave, creating a frequency shift that mimics the sacred Quetzal bird. Generating hydraulic pressure, filtering municipal water, and tuning acoustic frequencies requires a mastery of physics that simple manual labor cannot explain. These were intentional, calculated choices. The physical evidence of seismic defense, subtractive carving, and acoustic physics actively breaks the accepted timeline of human engineering. These aren't the products of a primitive society doing basic labor. You don't accidentally engineer water filters or build colossal acoustic instruments using only copper chisels and hemp ropes. To understand our past, we have to look at the evidence. The mechanical genius proven by these ancient monuments demands that we reevaluate what our ancestors were truly capable of achieving. The physical evidence of seismic defense, subtractive carving, and acoustic physics actively breaks the accepted timeline of human engineering. These aren't the products of a primitive society doing basic labor. You don't accidentally engineer water filters or build colossal acoustic instruments using only copper chisels and hemp ropes. To understand our past, we have to look at the evidence. The mechanical genius proven by these ancient monuments demands that we reevaluate what our ancestors were truly capable of achieving.